This is lesson 2.5. We are testing equivalence. So we've got no new vocabulary words here, but our big idea says you can test whether algebraic expressions are equivalent using a number of different things. We can use substitution, which we're going to try today, tables, graphs, or properties. So example number 1, we are going to start with a table. Fill in the table are the expressions equivalent. So before we run the numbers, let's talk about what we're going to do. We're going to plug in each one of these numbers in for n. We're going to evaluate it or simplify it and get it all the way down to one single answer because it'll be just numbers. And we're going to do the same thing with this expression. And if all of the answers appear to be the same, then we can say that they're equivalent. And if they're different, then we'll say they're not. So this is just one way to prove equivalence. This is a combination of substitution and table. So we're substituting a number in to both of these expressions, creating a table and seeing if they're a match. Now, we talked about last section about how you can't just plug in a positive number and see if they match. You always want to test 0 and a negative before you are pretty sure that they are equivalent. So we're going to do a little bit of that. So I'm actually going to start here, starting with some positive numbers, or even with a 0 would be super easy. So if I plugged in 0, 4 times 0 is 0, minus 7 is negative 7, and I probably want to start showing some work. We'll actually get to this question on the back, so you can go ahead and cross that out. And let's use the bottom here for our work. So I'm going to do 2 times, if I plug 0 in here, this becomes 4 times 0, 0 minus 7 is negative 7, minus, and then in here 5 times 0 is 0, minus 7 is negative 7. So multiplying here is negative 14, minus a negative goes plus plus, and negative 14 plus 7 is negative 7. So I got negative 7. So let's see what happens here. If I plug in 0, so let's go ahead and say that this is x equals 0. So our work makes sense here. So it's going to be 3 times 0 plus 2 is 2, minus 13. So it's 6 minus 13, and that is negative 7. So these appear equivalent. They do produce the same answer for 0. So let's move on to some positive numbers. Let's try x equals 1. If I plug in 1, 4 times 1 is 4, minus 7 is negative 3, minus 5 times 1 is 5, minus 7 is negative 2. So when I multiply, I get negative 6. It goes plus plus. Oops. Plus 2. And my answer is negative 4. And if I do that over here, plugging in 1, 1 plus 2 is 3. So this is 3 times 3 minus 13. That's 9 minus 13, and that is negative 4. So far these do appear to be equivalent. Let's plug in 2. 4 times 2 is 8. Minus 7 is 1. So it's going to be 2 times 1 minus 5 times 2 is 10, minus 7 is 3. So this is 2 minus 3, so negative 1. Plugging in 2 here, 2 plus 2 is 4, so it's 3 times 4 minus 13. That's 12 minus 13, and that's negative 1. So far so good. But we have also seen numerous examples where positives work and 0 works, but then negatives do not. So we have to test those negatives out. Slide up a little bit here. Let's start with x equals negative 1. If I plugged in negative 1, 4 times negative 1 would be negative 4. And negative 4 minus 7 is going to be negative 11 times 2. And then inside parentheses here, 5 times negative 1 is negative 5. Minus 7 is negative 12. So I'm going to get negative 22. This goes plus plus. And that's 12. And so my answer there is negative 10. So let's see what happens over here. We're plugging in negative 1. So negative 1 plus 2 is 1. Minus 13. So it's 3 minus 13. And sure enough, that's also negative 10. So if I was just doing this myself, I'd probably stop there and say, yeah, these are equivalent. But we were given a table, so we're going to finish it out here. So I'm going to just slide this down a little bit. We're plugging in x equals -2. So 4 times -2 is -8 minus 7, it's -15. Looks like this. And then plugging in -2 here, 5 times -2 is -10 minus 7, it's -17. So 2 times -15 is -30. That minus a negative goes plus 17, and that is -13. And -2 here, -2 plus 2, that's 0. So it's 3 times 0 minus 13, so 0 minus 13. And sure enough, I get -13 for both. So are the expressions equivalent? We would say yes, and if they did ask us to explain, which they didn't, but if they did, we would say similar inputs produce similar outputs. So the numbers we are plugging in for x would be considered our inputs, the answers are our outputs, and similar inputs into both expressions produce similar outputs. So therefore, it is completely plausible to say that these are equivalent. Now that's the old-fashioned way, right? And that takes a lot of time, and that doesn't necessarily pertain to what we've been doing in class, right? We've been simplifying these without plugging numbers in. So let's take a different approach. If you flip this over, example number 2, these are actually the same ones as you look. There's x's instead of n's, but 2 times 4x minus 7, 2 times 4n minus 7. Okay, so we're looking at the same ones. So we already know that these are equivalent. We've already shown it with the table. But we're going to explain now that they are by simplifying. So we're going to use a different strategy to prove that these are equivalent. So we're going to simplify this completely using all our tools, the distributive property, same thing here, and see what we get. So 2 times 4x minus 7 minus 5x minus 7. If I'm going to simplify this, I have got 2 little distributive problems to do. The 2 is going to get distributed here, and this negative is like a -1 that's going to get distributed. So I'm going to get 4 new terms, and then we're going to combine the like terms. So 2 times 4x is 8x, and 2 times -7 is -14. Now before you start writing a minus, you have to distribute, so be careful. -1 times 5 is -5x. And now this is a -1 times a -7. So that's a +7. Like terms, that would be your x and your x. So it's an 8 minus a 5, that's a 3x. And your -14 and your +7, those combined, -14 and 7 is -7, so we write -7. So we're going to go ahead and simplify this one now and see what we get. So distribute, 3x plus, multiply, 6. Combine like terms, there's no other x, so the x stays, and 6 minus 13 is -7. Take a look at these two expressions. They simplify down to the same thing. So are these equivalent? Yes, they simplify to the same expression. So we've proven that they are equivalent just using a different strategy. So we've proved it by simplifying. So if you're given 2 expressions and you want to know if they're equivalent, you can simplify them both and make sure that they simplify to the same thing. So instead of making a table, this is just a different way to do it. So we're going to do the same thing here now on number 3. We're going to focus on simplifying as our strategy. So explain by simplifying. So let's start with this one. Notice I have x squareds. Those would be like terms. So first thing I'm going to do is I'm going to start distributing. So this doesn't have anything to distribute. So that part stays the same. But before you start writing anything down, this is a -8 being distributed to both numbers on the inside of parentheses. So a negative times a positive is a negative. 8 times 3 is 24. The x squared just tags along. A negative times a positive 4 is a -32. Now all I got to do is just combine my like terms. So an x squared and an x squared will go together. This is a positive 2 and a negative 24. So that's negative 22x squared. Positive 3, negative 32, that is negative 29. So this simplifies to this. Let's see what we get here. I don't have any distributing to do here. All I have to do is combine like terms. So I have a x squared and an x squared, negative 27, positive 5, that's negative 22x squared. So far, so good. And I have a 1 and a negative 30. If I put those together, that's a negative 29. So both expressions simplify down to the same expression. So are they equivalent? Yes, they simplify to the same expression.